for almost 2 years running. I have 107 people per day. Oh wow, moving here.
Yeah, I've heard that too. Yeah, depends on your view of it, right? Yeah, that's what you're saying. So tonight we're going to do a couple of things. One of them is we're going to graph some quadratics and stuff. That's actually an 8.5. Okay.
So we're skipping 8.2 and 8.4.
8.2 they're skipping. I want to go do 8.4. Yeah. But I would have done the graphing quadratic stuff first, personally, but that's not the way that the guy kind of laid this out. So, all right. Also, then with that, we're going to take a look at this whole idea of what a complex number is. Okay. So, and I guess we'll do that first, and then we'll kind of finish up with the graphing part. The graphing part's a little bit more, to me, more interesting, but might be a little bit more difficult. So anyway, let's take a look at the complex number part of this. All right, first. So here's the deal. So when we, for those of you who kind of started in math 60 and so forth, you know, at some point they said, well, there's all these number systems, right? There's the whole numbers and the integers and the irrationals and the rationals, and all that makes the reals, and then they probably said that's all the numbers, you know, all in one big pot kind of thing. All right. Well, the problem is then is what do we do with this? So if we have a square root of a negative, okay, so the question, well, what do we do with that? Because I guess this has some applications in electricity, and I can't remember, there's a couple of other real world things out there where complex numbers come into play, so we had to have a way to deal with them. So what a long time ago a mathematician says, well, we're going to take, anytime we have a negative square root, all right, we're going to make that into an I, and we're going to call I the imaginary number. So imaginary number is just equal to the square root of -1, and it's symbolized by an I. Okay. So what that does is that allows us to take the square root of -7 and write it as I square root 7. So basically all that happens is, because I is equal to -1, is that this negative goes away and the I goes out in front of it, because I is equal to the square root of -1. So if we took the square root of -1 times 7, we know from multiplying square roots that that's what you get. Right? So you're just kind of taking that -1 out of there, replacing it with an I on the outside of the square root.
Just the simple, timesing it by a negative to make it a positive. That's
kind of what we're doing here, right? Right. So whenever you see an I, then that's what they mean is the square root of -1. Okay, so like I said, what that does is says, well, anytime if we have, say, the square root of a -21, then that's just equal to I square root 21. Okay, so we're just taking that negative basically and replacing it with an I, because I is equal to the square root of -1. Okay, so that's what an imaginary number is. Now, if we take all the imaginary numbers and we put them together with the real numbers, then we get what we call a complex number. And a complex number takes the form a plus bi, where a and b are just real numbers. But the b has an I attached to it. Okay? So if you hear about a complex number system, then that's just all the real numbers and the imaginaries. So every number that you've been taught about up to now is also complex. Okay, because complex can be any number. It could maybe the b is 0. Okay, so maybe there isn't any i's. Well, that's still complex. So when we talk about the square root of 10, that's a complex number. When you talk about 5, that's a complex number. All right, so that's all that they did is just take all the reals and imaginaries, put them together, and we got a complex number. Okay. Bless you. So those are our complex numbers, all right? And what they like in the book here, what they're doing with them is they're doing some simplifying and basically solving equations with the quadratic formula, okay? So I'll show you some simplifying things here. You can add these, multiply them, subtract them. I think you do that in 95. Simplify, I guess I'll just say simplify because that's really all we're doing. Okay. So if we have, say, a negative 16, square root of negative 16, okay, so then the I is going to appear, the negative is going to go away, so we're going to have I square root of 16, but we can take the square root of 16, what's that? 4, so we just get 4I, right? So that's all you do. Okay, so the negative's just nothing to get it, just bring the I out. The negative goes away because it's equal to the square root of negative 1. And we get square root of 16, which is 4. Right, so if we have square root of a negative, say, 48, okay, I is going to come out in front. We just got to break down that 48. We did a whole bunch of this about a week or so ago. So let's see. What goes into 48? How do we break this down? 16 and 3. Okay, good. So that's going to be equal to what? What are we going to get then? 4I square root 3. Yep. Okay, square root of 16 is 4. And then square root of the 3 stays along inside the square root.
I stays with the square root?
The I goes out in front because it's remember I is equal to the square root of negative 1. Yeah. So it's just a multiplier, right? So it's just sitting out in front of that.
Because when you have I with the square root of 16, would it be I4, or does it have to be I?
No, I4 is okay. It's just that they usually always put that variable. It's not really a variable, but the letter at the end. So it's like how you have 4x instead of x4. So it's the same idea. So even though it's not really a variable.
But in the sense that it has a square root, the I needs to be.
Oh, I see. They do that because, well, here's why I think it's done. I don't know where that I is. Is it underneath the square root or is it not? You see how it's hard to tell.
Would it be in front of the 4?
No, you always want to have, in this situation, you want to have a number before the I. That's just how it's usually written. So it's 4I square root of 3. And in this, and in the case where, let's see, how about if we had this? If we did this, negative, say, I'm trying to think of a good one, 34. Okay, so then this would be I square root of 34. Okay, but if I can break it down like this one, then I'm going to put the number first. Okay. Let's see. They have some like this too, I see here. I don't exactly know what they're trying to accomplish with these, but so here we have 3 plus negative square root of 2. Oh, can't have that. All right, so we're going to get an I come out in front of that square root of 2, but I can't combine these because this one is real and this one's imaginary, so they don't combine. Okay, they're different. Even though it's a complex number, they're not the same thing, so we can't combine them. It's like when you have a 3x and a 4y, you can't combine it and get 7xy. Alright, so they're that kind of a difference. So we just write it as 3 plus I squared root of 2. Any questions on that part? Okay. So then really what they want you to do with these is solve. Okay, so on our final now, okay, then when I say solve and we're talking about these quadratics, then I'm going to assume that we're going to do it under complex numbers. All right, so that means that when you're solving these, you want to break it all the way down to a complex. So for example, let's say we have x plus 2 squared equals negative 10. Okay, so we have this, right? Well, what do we did some of these on Monday, so what do we have to do to figure this out? What's our first step here? Yeah, we're going to square root, right? Okay, so I square root, that goes, I get x plus 2. Now here, okay, I know I'm going to get plus or minus because we talked about that Monday. And I would have probably said, hey, I don't have a real solution here. You know, everything you did in A3, if you got a negative, I don't know if you ever did, but if you did, you just say, there's no real solution, I'm done with that. But now, we say, nope, that's not the case, because how can we rewrite this, now that we know about imaginaries? I square root 10. Okay, so then we would subtract 2, and we would get x equals negative 2 plus or minus I square root of 10. So this so then now, on our, like I said, on our final, we have to make sure that when we're solving these quadratics that we do it with complex numbers. The procedure doesn't change, it's just we're going to have complex numbers now. Okay, so let's say we have one like this. All right, obviously what's our first step going to be? Yeah, we're still solving, so we're going to square root. Okay. So what are we going to get on the left side? Yeah, x minus 3, because square is going to take square root, is going to go away. What about on this side over here, though, on the right side? We got a negative, so that means we have an I. So it'd be 5i. Plus or minus, though, 5i.
5i or I5?
It's 5i. Okay? The number comes first. So, we have 5i plus or minus, can't forget that. And now we just add that 3. But again, we can't combine these because one of them's an imaginary and the other one is real. So we just leave it like that. So now, let's still solve, but this time we'll use a quadratic formula. So A equals 1, B equals negative 8, C equals 12. And now we'll use the formula. And again, it depends on how far you want to carry this out. Oh, this one's not going to be imaginary. Gosh, got it. I didn't make that number big enough.
Changes this 4 to 6.
Yeah, I just tried 14 and that ain't going to work either. I know 18 will. 18 will take care of it. Sorry about that. I thought 12 would work, but there we go. 18. over 2. So 8 plus or minus 64. That's what I get for using 8. And 4 times 18, 72. So then we're going to get 8 plus or minus square root of negative 8, correct? Over 2. And there's our negative. So then, you know, on your assignment, then you would have said, oh, yeah, no real solution, can't have a negative underneath there. But now we can deal with it because we know about imaginaries. So we're going to have an 8. And then how are we going to, what's this going to look like? I is going to come out in front. Square root of 8 over 2. But, we can break this 8 down. And we probably, I bet you've done enough of those that you know what it is. Yeah, 2 and 4. Or 2 and 2, I mean. So we have 2I square root of 2 over 2. And then, boom, boom, boom. Finally, we get it. So really the only difference between this problem here and what you would have done before is just the I. Okay? Everything else is the same though. It doesn't really change a lot. It just introduces that I. The formula doesn't change, it's just, you know, introduces the I. You want me to do another one like that? Okay. I lost my green here. This time I'll make sure it works. Okay, so here we go. Now, if you try this in Desmos, by the way, it won't work. I think I showed you that on Monday, right? If you type it in, undefined, I think is what it says. I can't remember exactly, but it won't work. So that clues you that it's an imaginary solution, and you have to do it by hand. You have no other way of doing it. Okay, so we're going to get 2 plus or minus 4 minus 3 and 9 over 6 this time. So what are we going to get on the inside here? Let's see.
4 minus
108. Oh, so there's my negative. So what's this top thing going to change to? Well, we got a negative, right? Going to have an I. Now 104.
I'd go to square root 10 and square root 2, which it's square root of 100 and square root of 4, which is
4 and does 4 go in there?
4 and I was thinking it would be you could do
Yeah.
square root of 10 or square root of 100 times square root of 4.
Well, I think you're thinking of, but that would be adding.
Oh yeah.
But I think 4 does go in there. 26 times, I think. So we can take this. This I is going to come out. Oops. 2 is going to go there. 26 over 6. So reduce, reduce. So this is reduced here. So I'm going to get 1 plus or minus I square root of 26 all over 3. 2 goes in here, 2 goes in here. Okay, and you have to go. It has to go into both of these. All right. So if this was a 5, then you just leave it, right? Because you can't take 6 into 5, so you would just leave this. You wouldn't even do that one. just leave it alone. It has to be reduced in each one. Hey, do not want we good now? You'll get it. Yeah, sure. You can do as many as you want. There we go. Okay, so we get x equals, using the formula, so it's just going to be opposite b, so plus or minus there. 49 minus, let's see what we're going to get here. So we're going to get 4, 2, and 15. So what are we going to get underneath this one now? So we got 4 times 2 times 15.
Negative 120.
120? So 49 minus 120?
Yeah.
What's that?
71.
So the i's got to come out in front. 71, can't do anything with that one. Can't reduce anything. So we're done. So again, we're just using the quadratic formula. Okay, you're going to get some negatives. Throw some i's and come out and become an I. You might not. Maybe you don't. Sometimes you do them, you don't. All right, so it just doesn't change anything though. Still using the formula. Okay, so and I'll give you something to practice on tonight for sure. So our last section then, for tonight anyway, I'm just going to speak a little bit about that and I'll get you a break here. So talking about graphing, which is what we're going to spend probably most of our time on, these quadratics. Okay. First of all, there's 3 forms. Okay. So there's this form, which you have dealt with a lot. Then there's this form, which you have seen a little bit of when you factored. And then there's that's with lines.
Oh, yeah.
And then this one, which is one that we haven't seen at all. Okay, so this is like a general form. That's what we call that, general form. Okay, this is a factored, sometimes called intercept form. I'll write that below. And this is called vertex form. Okay, so those are the 3 forms that you can write a quadratic, and they're gonna, anything is gonna take one of those, look like one of those guys. Okay? And so what we want to do is be able to, tonight, is hopefully, we're going to take a look at this one, and if I give you an equation that looks like that, you should be able to graph it, sketch it quickly, just like that, okay, and know what's going on with that, okay. Kind of the same with this. This one here is very difficult to graph from. All right, it doesn't really tell you anything about the graph. Okay, it's just convenient because it's kind of tidy looking. All right, excuse me, but it doesn't really help you with the graph part. These two do. Sometimes, and I should have put this in front of this guy right here. There's sometimes an A out in front of that also. Okay, so we're going to take a look at these things. All right, but this is really a pretty good time to pause. Maybe a little bit earlier than usual, but so let's take our quick break now, and then when we come back, we'll look at these three forms from a graphic standpoint. So we'll do a lot of Desmos stuff. I'm just going to do this here. Let's jump right into this.
Pacifier stuff. It's a dark electronic beat. It kind of reminds me of what's got that nice kind of dubstep issues. If it's got that noise in the background.
Okay, so I wish I could record this, but my tablet won't access the internet. So I'm just going to do this on Desmos, and it wouldn't be a bad idea for you to just kind of follow along with it a little bit so you can play and see kind of how things are going to work. What we're going to do is I'm going to graph some equations in that vertex form. Let me kind of just refresh that for you up here. And what we want to do is kind of figure out, first of all, what these things look like, and then kind of their important parts, let's say. So this was the vertex form that I wrote. Okay, so what we want to do is figure out what this does, what these two things do, or what they represent, what these curves look like. So to do that, all right, so I'm going to go into Desmos, and I'm going to go y equals, okay, and I want to make a slider like we did the other day. So I'm going to go A parentheses x minus, I'm going to put h squared plus k, and introduce some of these guys. Okay, I'm going to move this to 0 and move this to 0. All right, so this is our graph of any quadratic. It's a U shape. Okay, it's called a parabola. All right. And our U shape has one kind of important feature besides the fact that it's opening up here. It has something right down here at the very bottom. Okay, and that's called a vertex. And I will put all this back on the tablet so it's getting recorded. And that's called a vertex. So in a parabola, and the reason why we spend some time with quadratics is because this motion, although it would be upside down, is really important. So like if I throw the marker, okay, like across the room, you can see that makes that parabolic motion. And it reaches the top part someplace where my force of throwing it up finally loses and it starts to come back down. Okay, so that point is called the vertex, okay, which is right there. All right. Also, if you think about it, you see that a lot, right? Okay. Yeah. I mean, so there's lots of arches in different things, and they're supposed to be a nice appeasing thing for people artistically. Right? Also, okay, bridges. You see a lot of arches for bridges, okay, because of the strength of an arch. So there's lots of different reasons for talking about these things, besides just doing it, okay, because they do have some applications. So in our parabola, we have this, again, U shape with vertex here. So if I take this A value and I move it around, so let's say I move it so that it's getting bigger, what's happening to that curve? It's getting smaller. So we say that's sort of narrowing, all right? And really it's called what we call a vertical stretch. That's what we call that. Okay, so it's getting stretched vertically, but it's really narrowing. All right, and we're going to put all this together. Okay, so you don't need to scramble to write anything down, because I'm just going to put it all on the tablet for you, and we'll just go over it all together. But the A is definitely narrowing that curve. Okay. Now let's say we go in the opposite direction. So now I'm going to get smaller. So what's happening to the curve now? It's getting wider. Okay. Until I get down to the negatives. And then what happened to it?
It's all messed up.
It's all messed up, he says. Well, where did it go? Here it's up, and now all of a sudden it is up and now down. Okay. So when it's a positive A, we have a curve opening upward, but as soon as we make it negative, that curve's opening downward. All right, so that's what this A does. All right, it still narrows when it gets large and wider when it gets that, but as soon as you go down into the negatives, that curve opens downward. And the reason we just call that a reflection. All right, so it's reflecting over the x-axis. All right. So that's what A does. All right, so it controls the curve's narrow and wideness, and whether it's going to open up or open down. So you can see why when I was tossing that marker and we were getting that parabola that was going downward, well, I don't see that. This parabola's U-shape upward. Well, all you'd have to do is make the A negative, all right, and now we have it opening downward. Okay. All right, so let's make this back to 1. And now we're going to play with H. Okay, so I'm going to take the H and move this H. And what is the H? How does that affect that U-shaped graph?
Moves it on the X.
That moves it along the X. Okay, same thing if I go this way. Now, one thing we have to be careful of, all right, is here, this is an X minus H. So if H is a positive number, all right, what that looks like right now is Y equals X minus 3.8 squared plus K, which is 1, or K, which is 0. All right? So even though this is a minus, you think, oh, it's going to shift it to the minus. It doesn't. It shifts it that way because the H is this number here, right? And the minus drops down there. So if I have H at 3.8, then that just means it shifted H positively. Okay, so it's, even though this is a minus, that minus comes from here. Okay, it has no bearing on the H. The H is positive, so it shifts that way. All right, now if I bring it back, okay, so the H is negative. All right, now this equation would look like this, okay, where it's a plus because minus a negative 3.6 squared plus 0, and you'd say, but man, that's a plus. Shouldn't it be shifted that direction? It's actually, because this is a minus, it's shifting in the opposite direction. So if this is a plus, then we're shifting negatively. If it's a minus, then we're shifting that way. And that's because that's what the H is. Okay? It's the H that's telling you whether it's shifting along that x-axis, like Forrest says. Okay, so there's our H. All right, I'm going to get this guy back to 0, and let's look at K. All right, so what is K doing? Goes along the y-axis. Okay, and that one's nice because it's plus at the end there. So if this is plus 2.6, then all right, it's just up 2.6. All right, if it's down, then it's just down. Okay, so this is what our graphs are going to look like. and you can see that this vertex form, if you understand vertex form, you can graph any of these you want. Now that you're using Desmos, you just sketch them because you know things. The one thing that we're interested in too, again, is this vertex, all right, which right now is 0 and 0.7. So if I change this to here and change this to here, now let's see what my vertex is now. What does it say it is? 4.3 and 3. Well, where's the 4.3 and the 3 coming from? H and the K. All right. So guess what? What are these two numbers going to give you? To what?
It's going to give you the vertex.
It's going to give you the vertex. Okay? It's going to give you the vertex. That's why it's called vertex form, because it gives it to you. All right? So if you have an equation written in that form, you know where the vertex is. This tells you whether it's opening up or down. You can graph it. And you don't need to do anything, type it in at all. All right? Help if I turn that on. Okay, so in vertex form, we just said that the H comma K is the vertex. That's the vertex. So if I have y equals x minus 2 squared plus 3, then the vertex is going to be, and we got to be careful here, what's the vertex going to be? 2, 3. Not negative 2, right? Because this negative and this negative over here, h is 2, so it's going to be 2, 3. All right? So if I know where the vertex is, I can make a little graph. 1, 2, 3, 1, 2, 3, 2, 3. There's my vertex. I don't have an A in front of here. It's just 1. Okay? So then I know it's opening upward because it's positive. And, oops, I missed a vertex altogether. Let me try it again. There it is. Okay? So see, I can sketch one of these guys if I understand vertex form. Okay? I can do it without graphing it. I bet you can do it faster than you could in Desmos, okay, if you understand vertex form. So let's check out. So here, let's write down some of the stuff that we said. So A, right, well, how does A affect the graph? Well, if the bigger the A, or larger the A, I guess, right, larger the A, okay, what does the larger A do to the graph? What did we say?
Slows it down.
Not A. It does what? Widens or narrow, but the larger the A is going to narrow it, right? So it's going to narrow the graph. All right, narrow the graph. So if A is a big number, your graph's going to get narrow. And of course, then the smaller the A, and what we mean by that is A's between 0 and 1. Okay? So we're making it a decimal. What happens to the graph? It widens. All right? And what happens if A is less than 0? Then what happens to the graph? It opens down. Okay? Opens down.
Also, did you start recording this part once you got back into this?
It's been going the whole time.
I thought you said you couldn't record this.
I can record it, but I just can't show Desmos on here because I can't. For some reason, I can't access the internet. I don't understand why. It must be some. It could be built into the tab, but I'm not sure. Okay, so it's going to open down. All right. So the larger the narrower the graph, the smaller, it widens it. If A is less than 0, it opens down. And the big thing is that the H and the K is the vertex. H is sliding it horizontally. Okay, H, we can just say slide horizontally. And K slides vertically. But they're the vertex, and that's the big thing.
And what's this form called again?
Vertex form.
Vertex form, okay.
So if we're asked to sketch a graph, and state the vertex, here we go, y equals 2 parentheses x plus 1 squared minus 3. All right, so then what should be able to happen is we should be able to sketch this and state the vertex. So if I go like this, okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. All right. First of all, I'm going to look at find the vertex. Okay, H and K. Here's my vertex. H, K. So what would the vertex be? We have to be careful. -1, -3. All right, because remember, it's minus, so it's going to be the opposite of that. -3 just drops down there, so that's nice. K is just K. All right, but H has got to be the opposite. So it's -1, 3. So I'm going to go to -1, -3. I'm going to put a dot there. That's my vertex. Now I'm going to look at the A. Is A positive or negative? Positive, so that means it's opening up. Okay. Now I'm not going to get too excited about whether you make it wide or narrow. Okay, because it's kind of hard to figure that out. But I just want you to see it. All right, opening up and down. Okay, make sure we get the vertex right. Okay. So it's really nice to sketch these when they're in vertex form. Okay, because you can do it without even having to.
So is the A how many how much is in the middle of the x-intercept? How many ticks are in the middle of the x-intercept?
A is just narrowing, widening it, stretching it. There's no real. It's a factor. It's hard to explain exactly. It's not gonna.
How do we know if we're like graphing like that? How do we know how wide to make it with a different A value?
So this is just a sketch. Okay.
Okay.
If you want something accurate, then you would probably do some sort of technology on it. That would be my response to that. Okay. All I'm looking for is positive A's are opening up, negative A's are going to open down, right? So if that number is 100, then yeah, you'd probably narrow it a little bit. Okay.
And if it's 0, the line's flat then, right?
Yeah, you don't get those. That's not even it's not the equation gone.
Yeah.
Yeah. Okay, so let's try this one. Okay, I'll take a look at it. So what's the vertex? 2, 1. Okay, again, it's minus. We can take the opposite, right? So then we're going to do this, oops, do this. Okay, so let's see. 2, 1. There's my vertex. Now I'm going to look at the A. Which way is it opening? Down. Okay, so I'm going to go like this and make it open down. All right. And that's it. Okay, so see, if you can do that, that's awesome. Okay, if you kind of understand how that works. So the other form that we had, not the general form, but this one, Okay. This is called the factor or the intercept form. So if I go into Desmos for this, all right, and graph this one, you'll see this pretty much right away. And we've already talked about this, so I'm going to take this and get rid of it because we don't need these anymore. Oops. I'm going to type this in. Y equals parentheses x plus 2 parentheses x minus 3. So I'll put that one in there. All right. Notice where the graph crosses the x and y axis. -2, or not the y axis, sorry, the x axis. And 3. Well, where are those numbers coming from? Coming from these guys. Okay? It's just the opposite, right? And that's what we talked about when we were factoring these. Remember I said, hey, if you graph them and you get the x-intercepts, you'll be able to see if your answers are right or not. Yeah, well that's, now we're just bringing that back.
And you know since it's x plus 2, that the intercept's going to be minus 2 because it's, I see.
Yeah, because it's the opposite.
That makes
Okay.
a lot of sense.
All right, and mainly because it's equal to 0. So -2 plus 2 is 0, and 3 plus -3 is 0.
So if it would look just like a problem we've seen if we replace that y with a 0, same difference.
Yeah, yeah, because that's basically what you're doing. So at -2, when x is -2, y is 0. Okay? They're actually called zeros. Okay? They actually call those zeros.
So would it be possible to you know how with lines we can switch from slope intercept form to point slope form?
Mm-hmm.
Would it be possible to go from like intercept form that we just did to vertex form with this?
Yep.
How would we distribute that to get to a different form?
Are you taking Math 95?
Yeah, will we do it there?
Mhm. Yeah, I'd rather not do it here.
Okay.
I think we get this figured out, we'll be in great shape. All right, so let's try this one out and get rid of the purple one. Notice I put a negative in front for it. That means it's going to open down. Okay, look at our x-intercepts. Right? 1, -3. 1, -3. So now you know what those things do, but you kind of knew that before anyway. All right, so this isn't anything that's completely new. Okay. So I'm going to switch back here again. So these C values that I called C1 and C2 are your x-intercepts, which again is why this is sometimes called intercept form. Those are your x-intercepts. All right. So you can kind of graph these ones too without having a whole lot of, without using Desmos, because you can just go ahead. All right. And I look at this. Let's see. I got one like that, like that, like that. Okay. So I'm going to go -1. There's one x-intercept. 1, 2, 3, 4. There's another x-intercept. And then I'm going to graph this. Okay.
So then that would be an acceptable answer?
Mm-hmm. Yeah. For a sketch. Yeah.
Can you get the vertex out of that?
Now, yeah, I was just going to say that. The problem is we don't know what the vertex is, right? But you can figure it out because the vertex, this point, is in the middle. Because these things are symmetric. All right, this is called the axis of symmetry, which I think they bring that up a little bit, but I don't emphasize it a whole heck of a lot. So this is the axis of symmetry here.
You can tell what x is at.
You can tell the x, huh? How can you tell the x?
Because you can just find the middle point between the two.
Right.
Find the difference and just find the on the graph.
Exactly. So you can find the middle point. So if we took -1,
For that one, I just checked it out as well. It's the 1 and 4.
So it's 1.5 because we're going to add these, huh? So we're going to get negative, so we're going to get 3 over 2, which is 1.5, yep. Okay, and then the y value, a little more complicated. You'd have to take and substitute this in to that equation, all right, and then just type it in your calculator or whatever, and it would give you whatever that y value is. Okay, but you're not going to have to do a lot of that, all right?
Why did by 2? Is that the sentence?
Because we're finding the guy in the middle, so it's like an average. So if you have 2 test scores, you want to average them, you take 1 plus the other and divide by 2, right?
But is this the same thing where if we had a value for A in the front, we just trying to make the column narrow and wide?
You just estimate it. And if you wanted to be accurate, you could graph it, right, using technology. So that's intercept form. All right. Now, general form, again, it doesn't. You can graph it, but the A and the B and the C don't have anything to do really with the graph of it, right? So, and I kind of showed you that. I'm sorry, I'm bouncing back and forth here, but we did that the other day. I'm pretty sure we did. So I type one of these in. Okay. So if we go A x squared, all right, plus bx plus c. Okay, and I did sliders on all of them, and I split them. All right, so it really doesn't give us anything. All right. So in other words, see, there's, if I move this around, okay, let me get this back to a decent number here. All right, yeah, I get the up and down thing with the A, but the B doesn't give me any movement, any direction. It's kind of weird looking. All right, and C kind of moves you up and down, but it's also affected by B. Okay, so this particular form doesn't really help us a whole lot graphically. I couldn't really tell much because of that B. If I tried graphing one of these, I wouldn't know where to start. All right, I wouldn't know. So with that being said, of course, guess what kind of forms they have in your book? General form. Okay, so these are the ones that we're going to see. All right, well now, thanks for telling me all the other good stuff. How do I fix this? Well, first of all, they're going to ask you questions about, do these guys open upward or downward? Okay, so if I have this one here, and let's say I put one like this, okay, all right, one like this. So, upward or downward? Upward or downward? How do you know? Because A is positive, okay? And this A, and the A that's in front of vertex form, and the A that's in front of the vacuum form are all the same A. It's all the same. So upward, down, down, okay? That's how I tell. All right, so I don't have to worry about any of that stuff there. Okay. The next thing they want us to be able to do is, this is all general form, wants us to find the x-intercepts. Find x-intercepts. Okay, so let's start out with one of those. So let's go like this, all right? I want to find the x-intercepts. Well, okay, how do I do that? Well, you can't really put it in that form, but you sure graph it, right? You can go into Desmos and graph it, find out what the x-intercepts are, okay? You'd have to factor it, okay? But that doesn't factor. Right. Yeah. That's because you can't factor it. Because it's a negative 10, and there's only 2 and 5 and 1 and 10, none of them give you 8. So the thing, that's why it doesn't, factoring doesn't do us any good there. But we can graph it and find those x-intercepts. Okay? Now, the other thing you can do, and you might remember this from Monday, is we can use the quadratic formula on this. because the quadratic formula also tells us what those x-intercepts are. So if I go 1, 8, negative 10, and I use the quadratic formula, it tells me what those x-intercepts are, because I remember saying to you about how, you know, if you want to check your answers, you can use Desmos to do this. So let's see, we're going to get 4, that's 40, 104 over 2. All right. Oh, hey, that's 104 again. We got that already once today. Let's see, so that was 2 out front and 26 inside. 2. Problem is, I don't know what those x-intercepts, I mean, that's x-intercepts, but if I go and graph it in Desmos, it's not going to tell me that. It's going to give me a decimal. Okay, so then what you'd have to do is just go ahead and graph it. Alright, so I'm going to bounce into here, and I'll come back to that screen, so let me get rid of all this stuff. I don't need it anymore. So we're going to go into this. Okay, y equals, what do we have, x squared. I ain't even going to follow along. I mean, you could do some of these just so you know what the heck's going on here. 10, okay. Alright, now I don't see them. Where are they? Oh, there they are. Alright, so if I type this in, parentheses, negative 8, plus square root. See, that's what I said too, is that, you know, you want, here, we'll start from the beginning. It's a good idea to kind of put some of these in here, because then you'll know how to do it this way too, not just work them all out by hand. Divided by 2. So there's one of them, at least it should be, but I must have messed up somewhere. Oh, negative 10, yep, that's negative. That'd definitely make a difference. And 1.09, oh, that's that one. Okay, then if I change this to a minus, oh, there's that one. Alright, so they're both there, here and here, just from changing that sign. So the quadratic formula also give you the x-intercepts. Alright, so when you're doing those problems, you can either graph them or use the quadratic formula. That's completely up to you how you do those. Alright, and they even have them as decimals, so that's how you do that. Okay. Back to here again. The other thing it's going to ask you to do is find the vertex. So again, how do I do that in general form? Because if it's in that vertex form, man, then I can find it pretty easily. Alright? But here, not so much. Well, I'm going to have to graph it. Okay, to find that vertex. So then I would go into Desmos, alright, type it in there, look for where the vertex is. Alright, and then I would write that down. That's what the vertex is. Okay? Alright? So that's what you probably want to do. Now there is another way, okay, to do it. Alright? So you can either graph it, or you can use this guy, which is negative b over 2a, comma, I'm going to leave that blank. So you could go b equals 3, a equals 1, negative 3 over 2 times 1, negative 3 over 2. So if you graph that in Desmos, then your x-coordinate is going to be negative 3 over 2. Alright? Or excuse me, then I would have to take this equation and put that nasty negative 3 over 2 in for x and figure out what the y is. And that's how you would do the vertex that way. Again, I don't really care which way you do it. Alright, so when you get to your final and you have a question and it says, and a lot, what I might do is something like this to say, you know, hey, I want you to tell me what the x-intercepts are what the vertex is and sketch the graph. That'd be a fine question I would ask. Vertex, x-intercept, sketch the graph. So if it was me, I'd probably just graph it, because you know I told you can go in the Desmos, graph it, find the vertex, find the x-intercepts, sketch the graph. Okay, if it's in this form. All right, you can do the negative b over 2a thing. All right, but I don't know if that's you can. Okay, but then once you get the x coordinate, you got to shove it back in. Use a calculator, because you probably don't want to do that by hand. All right, because that'd be pretty messy. So those are the things that they're kind of want you to do. They do have some vertex form finally in here, also towards the end. But the rest of them are all going to be in that general form, and they're basically going to ask you to do those things that I showed you. Okay, which is a lot of stuff in that like 40 minutes of time. So, is there something else you want me to run through one of those again? Yeah? Okay. So let's just do this. So let's cover all of it. All right. Let's find x-intercepts. Let's find the vertex. And let's sketch a graph. So let's do y equals, I'll make one up here, 2x squared plus 6x minus 10. Yeah, it should be okay. So, yeah. So what are we gonna do? Find the x-intercepts. Okay. Well, I'm gonna have to graph it. Or what else could I do? Find the x-intercepts. We can graph it, and we can use a quadratic formula. Okay. Nope. I can tell right now. Because 2 times 10 is 20. So you got to find factors of 20. They're going to subtract the 6. So I don't think there is any. 1 and 20, 2 and 10, 4 and 5. No. But you could, if it was factorable, you could. Okay. So what do you want to do? You want to graph it? Or you want to do the quadratic formula? You're doing these. Graph it. Okay, go graph it. Find the answer. I'll let you do it. Go graph it. Tell me what the x-intercepts are. You do that. I'll work it out using the quadratic formula. See what happens here. Oops. So let's see. Oh man, this is nasty. 4.7 over 4. It's a little bit over 1. And negative 16.4, 16.7 over 4. Over 4 negative. So what'd you get? Did anybody graph it and get it? What'd you get? 1.1 and negative 4.1. Okay, that's about what I got. 1 point, yeah. Well, we got 10, so that's good. All right, so see, it doesn't matter. I mean, I just went through and you see what I did. We're at 116, got 10.7, and I just added and approximated them. That's a little squiggly ID. I approximated them, but I probably would have graphed it anyway. So there's my x-intercepts. What else did I have to do? Find the vertex. Okay. So how can I find the vertex? Yeah, graph and use decimals. I know. And I mean, right. So we have. Let's see. I gotta get the equation back up here. I forgot it. 2x squared plus 6x minus 10. Okay. So yeah, I graph it on Desmos. Figure it out. Just click on it. Okay, or negative b over 2a. Okay, but remember that's only going to give you the x, right? Okay, I still got to find the y. So negative b, so it's negative 6 over 4. The never is going to come out nice. I get 3 halves. Yeah, so then I would have to put that in, figure out what that is. Okay, my calculator is going to handle that. It's not very good. Negative 14.5. Okay, I believe you. But I would probably use, I'd probably use decimals to find it. But it's good that you know negative b over 2a. I mean, you don't. Yeah, it just doesn't. Yeah. Yeah, you don't. They asked for the y-intercept, but I didn't give you any of those problems because you hardly ever use the y-intercept on a. There's not. Yeah, it's just they really don't. Well, it's not negative 10. It's just been moved up and down, that 10, but that b shifts in it. So, yeah, it's not going to be negative 10. All the time, anyway. Okay, so that's that part. So, I mean, that's all there is to those, okay? Do you want me to do another one, or? Are you overwhelmed? Man, going like this. Overwhelmed? It is a lot to take in at one time, you're right. But you're really not going to, I toss those other ways in there just, to kind of give you a background. But everything they do is in that. However, when we do our activity, that vertex form is going to be your friend on that. Okay, that's where you want to go. And I'll give you an example of that on Monday. Okay. Well, go home, kind of try them out, I guess, and then Monday we do have some time on Monday to do some things. Those supplements are a little long, but we can kind of work through those. I'm not too worried about